Welcome to lesson number 2. We're going to be looking at rational expressions and equations and simplifying rational expressions part 2. So recall that from the first lesson we learned that you can cancel factors but not terms. This is going to be really important in this lesson. So let's start with class example 1a, where I have 4t cubed minus 9t divided by 2t squared minus 3t. So we want to begin by factoring my numerator as well as my denominator. So we're going to begin by pulling out my greatest common factor, which in this case between 4t cubed and 9t is t. So I can pull out t, which would leave me with 4t squared minus 9. And I can pull out t from 2t squared minus 3t, which would leave me with t times 2t minus 3. Now, if I look at this 4t squared minus 9, these are both perfect squares now. 4t squared and 9 are perfect squares. But it's also a difference of squares because that's negative. So this is going to be t times 2t minus 3 times 2t plus 3. And on the bottom, I have t times 2t minus 3. Now, another thing we need to remember is that when we're stating non-permissible values, which is what we want to do, we want to state the restrictions. Restrictions, also known as non-permissible values. So when I'm stating my non-permissible values, I want to make sure I do that before I cancel out any of my factors and state my polynomial in simplified terms. So before I cancel things out, well, actually I can cancel things first so I can get my simplified answer, since our restricted values go alongside our final answer. But this is where I'm going to find my restrictions. Okay, so right here is where my restrictions are going to come from, so we'll keep that in mind even though I am going to cancel out my factors now. So t and t can cancel out, those are factors, as well as 2t minus 3 and 2t minus 3. So my simplified form of this expression is going to be 2t plus 3. However, this comma is because we are going to also express our restrictions. T cannot equal 0, and it cannot equal positive 3/2. So that positive 3/2 comes from this 2t minus 3. So if I have 2t minus 3 and I set this equal to 0 and solve for t, then I'm going to add that 3 to this side of my expression, and then I'm going to divide by 2. T would equal 3/2. Now I'm going to do, and this is our final answer right here. Now I'm going to do this expression, and this, just like this one, you'll notice that we had our difference of squares come into play here. And those same types of factoring we're going to need to keep in mind as we factor an expression such as this. So 2x squared plus 5x minus 3. Now, something like this we can decompose or we can group. And when you decompose, you're going to group. So first of all, this 5x term we can break down. So 2x squared minus x plus 6x minus 3 over 2x squared minus x plus 2x minus 1. So this negative x plus 2x comes from breaking down and decomposing this middle term of x. Now that we've broken these down, now we can group them. So I put brackets around all of these expressions, and then I can pull out the common factors. So between 2x squared and x, I can take out an x, leaving me with 2x minus 1. And 6x minus 3, I can pull out a 3, leaving me with 2x minus 1. And on my denominator side, I can take out another x, leave me with x, 2x minus 1. And on the bottom here, I can take out a positive 1, leave me with 2x minus 1. And so when I group my terms, I'm going to start with my numerator here. When I group my terms, I'm going to be left with 2x minus 1 times x plus 3 on top. And on the bottom, I'll have 2x minus 1 times x plus 1 on the bottom. Now remember, this is where the restrictions are coming from, this point here. So with these restrictions, even though I am going to be canceling out some factors here, I do need to keep those in mind. So my final equation is going to be x plus 3 over x plus 1. And the restrictions on the variable are x cannot equal -1 and +1/2. In class example number 3, we're given the area of a rectangular field, and we're told it can represent 12a squared plus 25a minus 7, and then we're told the length can be represented by 3a plus 7. What we want to do is we want to write and simplify a rational expression that represents the width of the field. So my width is going to be equal to, so first of all, we want to think about the area of a field. Area is equal to width times length. So if I wanted to rearrange this expression, width would be equal to area divided by length. And that's what we're going to do here, is we're going to have width is equal to 12a squared plus 25a minus 7 over 3a plus 7. Now, in order to begin, what we need to do is we need to simplify by factoring 12a squared plus 25a minus 7. And in order to factor something like this, we can decompose it. And so 12a, I can do that over here. So 12a squared plus 25a minus 7 is equal to 12a squared. So what multiplies to give me -28 and adds to give me 25. So we would have, or sorry, not -28, but 84. And so we would have 28 and 3. So plus 28a minus 3a minus 7. And then we can decompose and group. So if I group these together, 12a squared plus 28a, I can factor out my 4a, leaving me with 4a and 3a plus 7, minus, if I have 3a minus 7, minus 1, leave me with 3a plus 7, and that's going to leave me with 3a plus 7 and 4a minus 1. So my width then is equal to my area, which factored is equal to 3a plus 7 and 4a minus 1, divided by 3a plus 7, which means that if I simplify, my width is equal to 4a minus 1, and that would be in meters. Now, if the perimeter of the field is 54 meters, determine the value of A. So the perimeter is the distance around an object. So if the distance around the object is 54 meters, we're going to find out what A is equal to. So if I have 2 times 3a plus 7 plus 2 times 4a minus 1, we know that that is equal to 54 because this is the perimeter and that is equal to 54. So if we simplify, we'd be left with 6a plus 14 plus 8a minus 2, and that is equal to 54. So 14a is equal to, so 6a and 8a is 14a, 14 minus 2 is 12, 54, subtract 12, 14a is equal to 42, and then 42 divided by 14, a would equal 3. Now lastly, the field has to be treated with fertilizer at a cost of $2.40 per square meter. We want to calculate the cost of the treatment. So we know the area is equal to 12a squared plus 25a minus 7. And we have a value of a, we have the value of a, which is equal to 3. So the actual area is equal to 12 times 3 squared plus 25 times 3 minus 7. If we calculate this, our area is equal to 176 meters squared. So the total area is 176 meters squared. So 176 times 240. 176 times 240 is equal to 422.40. Okay, our last example, we're looking at x plus 5y divided by x squared minus 25y squared. So I'll just skip these two and just focus on one of them for now. But again, we want to simplify where possible and say the non-permissible values for x in terms of y. So x plus 5y divided by x squared minus 25y squared. Well, first of all, if we simplify this, so x plus 5y, can't do anything with, but here we have a difference of squares. This would be x minus 5y, x plus 5y. Here's where our restrictions are going to come from, but our factors can cancel out, and that's 1 and that's 1, leaving with 1 over x minus 5y. Now x cannot equal 5y, so if x were equal to 5y, in this case, so 5y minus 5y would be 0. And 5y can't equal x, obviously, so if I were to replace 5y with x, again, we would be left with 0. So here's our final answer.